Welcome to the 64-bit edition of the Security Tube Linux Assembly Expert course and certification. Now in this video, we will look at the GDB analysis of the jump call pop shellcode for Execve. Now, as I'd always like to say, no assembly language code is really complete without a full-blown GDB analysis and looking at how the data and everything changes in the program. So this is really important because for all the low-level stuff, once you understand how things change byte by byte, I think pretty much you would understand how to manipulate the system. So here is what I'm going to do. I'm going to use the files from the previous video, and if you notice, we already have shellcode.c with the execve shellcode in it. We also compiled it, and now we are going to use GDB to analyze this file. There we go. Set disassembly flavor to Intel, and if you recall, the place where our assembly language code is pasted, just do a cat shellcode.c, is within the code variable. So let's do the following. You can just set a breakpoint for when we are just about to execute our shellcode. So we could do a simple run, lay out the assembly. There we go. Now the very first step is really our jump call pop, and if you notice, here is our call. So this position in here is what contains our string in memory. Could even open up the NASM file, and at the very bottom after the syscall and the call to shellcode, we have our string which we can verify. /s, space this, and there we go, right? Bin sh a 8b's and 8c. So let's step through this. We are at the call, just about to execute it, and if we verify at this point, this is how our stack looks like. And one more instruction, and the stack, or rather the top of the stack, would now contain the address to our string in memory. As you can clearly see, 601064, 601064. There you go. So the top of the stack now contains the address to our string in memory. After that, we do this regular XOR RAX, which is okay. Now pop RDI will take the address of the bin sh a 8b's and 8c string and put it into RDI, right? And we could easily do, or rather just print RDI, because you can actually do a print /x $RDI, and that points to our string in memory. Fantastic. Now let's try and see how this string is going to change. So let me do the following. Let me do a define hook stop, where let me go ahead and first print this address as a string. And then I can print this location as individual bytes as well. Let's say 25xb. To end. Now at this point, we have the whole string as is, right? Now the next instruction, move byte pointer RDI plus 7 AH, is actually going to move AH, which contains a 0, into A, right, which will ensure that bin sh would be null terminated. So let's verify that to a step I. And if you notice, now bin sh is what is displayed at that location. And simply because the position here 0, 1, 2, 3, 4, 5, 6, and 7 has been overwritten by null using AH. Now in the next step, we are going to copy the address of this string in memory into RDI plus 8 for the next 8 bytes, which means all of these 42s are going to be overwritten with the address. Here we go. And if you notice, now they've been overwritten with the address, right? And it's very clear if you read it in reverse order. It is 600164, which is really rather 601064, which is really this address in memory. Fantastic. Now the last step is to go ahead and overwrite all the C's with nulls, which is what we are going to do by moving the value of RAX into them. So here goes step I, and there we go. All nulls have been moved in. Now we would need to set up the addresses based on how Execve would function. So RDI would contain the address to bin sh, which is already set up. RSI would really contain the address to the argument array, which is located at RDI plus 8. And then finally RDX would be pointing to the null at the very end, which is nothing but RDI plus 16, or in hex you can say 0x10. Right? Fantastic. After that, we add 3b to RAX to set up the Execve syscall number, and then finally we call the syscall. So now with the help of GDB, you can see how clearly we are overwriting all of these values in the string bin sh a 8b's 8c to set up for the jump call pop execve shellcode to work as desired. So try this out in GDB, and if you're enjoying what you see here at Pentester Academy, then we would really appreciate if you can recommend us to your friends and colleagues in the InfoSec community. Thank you.